Hi! So for this video, we are going to talk about multiplying x times x versus adding x plus x. They are different, and sometimes students get them mixed up. So come along and... Okay, so I just wanted to take a minute to use the algebra tiles to show you, to give you a visual representation of what x times x would be. So if you think about a rectangle, if I have a rectangle, area of a rectangle is base times height, right? So I'm just going to use this grid to show you, okay, so if I have a rectangle and it was base times height, so let's just say that the length here is x and the width is x, or the base and the height are both x. That is just saying what my dimensions are. If I fill that in, check it out. It ends up being x squared. So base times height, if I had x times x, it actually does end up being an x squared. And now what if I add another x to that? So what if it was, let's say, 2x? So let's put a 2x up here, okay? Now we've got 2x times x. Well, if I fill it in, I would need another x. So basically now I've got 2x squareds, okay? Let's put another one down at the bottom. All right, so let's say I had, whoops. I don't want a negative. All right, so let's say I am multiplying now 2x times 3x. Here's my 3x's. So 2x times 3x, if I fill that in, I'm going to end up having 6x squared. And so if you look what happens, basically, I could multiply the 2 times the 3, which gives me 6, and then x times x is always x squared. Since we don't know what x is, we need to have that 2 up there to say that it's really x times x. All right, so that's a visual representation. Let's move on and we'll just talk about some other examples. Okay, so multiplying variable terms together, like I just said, if we had x times x, that is the same thing as x squared. Just like 6 times 6 is really 6 squared. But since I know that 6 is a 6, I could just simplify that to 36. Since we don't know what x is, it's just going to be x squared. So if I had a times a, that's going to be a squared. So anytime I have two variables that I'm multiplying by itself, it's going to be to the second power. Now just, if I had b times b times b, what do you think that would be? Okay, hopefully you said that would be b to the third power. So again, if I don't know what the number is and we have a variable there, then we can just add on to my exponents. If we have some numbers in there, so like in the last one I did 2x times 3x, well, I can multiply the coefficients together, which would be 6, and then x times x is x squared. So the numbers that we know, we can do that multiplication, and then the x times x would be x squared. So if I had negative 4a times negative 3a, that's going to be negative 4 times 3 is positive 12. A times a would be a squared. And just one other example, if it happened to be something like 3a times 2b, well, I can still do 3 times 2, which is 6. But the a and the b, they're not the same, so I'm not going to have any exponents. I'm just going to write it as ab, so that if somebody ever told me what a and b were worth, I could just then multiply everything together. Okay, so adding them is going to be a little different. Adding them, remember, we can only add and subtract if they're like terms. So if I had x plus x, well, remember that's really a 1x and a 1x, so now I have 2x's. No exponents, just 2x's. If I have 3x plus negative 4x, well, there's an x there. I can add the coefficients together, combining like terms, that would be negative 1x. Okay? If I had like the one up above, well, let's just say, so a plus a, that's 2a. But if I had 3a plus 2b, I don't have like terms. This one's an a, this one's a b, so they're not like terms. So therefore, my answer is just 3a plus 2b. There's nothing that I can do to simplify them. Okay? All right, so let's, diamond problems are an awesome way for us to practice multiplying and dividing. Remember, the top is the answer is the product, so that's the answer when you multiply. The bottom is the sum, that is the answer when you add. And so here I've got 3x times x, well 3 times 1 is 3, x times x is x squared. Now when I go to add, they're both like terms, 3x plus 1x is 4x. The next one, when I multiply, negative 2 times negative 4 is positive 8. I only have one x that I'm multiplying, so that's just going to be a positive 8x. And now when I add, they're not like terms, so my answer, or my sum, is just negative 2x minus 4. That's all that I can do. Okay, the next diamond problem, this one's where it's more like a puzzle. I need to know 3x plus what is 8x. Well, I know it has to be an x because I need to add like terms, and 3 plus 5 is 8. So that would have to be a 5x. And then when I go to multiply, 3 times 5 is 15, x times x is x squared. Okay, bottom left, same thing, it's like a puzzle again. I need to know, if I look at the numerical part, negative 6 times something is a positive 6. Well, I need a negative to make it a positive, and then 6 times 1 is positive 6. And then notice it's an x squared, so this is going to have to be another x, so that when I do x times x, I get x squared. Now they are like terms. Negative 6x plus negative 1x is negative 7x. And then last, I need two numbers so that when I add them, I get 3 plus 4x. Well, guess what? They're not like terms, so one of them is a 3 and one of them is a 4x, because I would not have been able to add them. And then when you multiply them, 3 times 4 is 12, and there's only one x, so it is x. Okay, hopefully this helps with the last part of Chapter 3. If you have any questions, make sure that you ask.